गुड मॉर्निंग सर। सर योर माइक इज ऑन म्यूट।
गुड मॉर्निंग सौरभ।
हाँ, गुड मॉर्निंग सर।
हाँ। हाँ, एक मिनट मैं अपना ना ब्लूटूथ से कनेक्ट कर लेता हूँ तो ज्यादा आसान रहेगा, क्लियर आएगी आवाज।
वैसे अभी क्लियर ही है सर, ऐसा कोई इशू नहीं है।
क्लियर है।
हाँ, वेल
ओके।
क्लियर।
हम्म।
सर अभी कुछ पार्टिसिपेंट्स मिसिंग है सर। कैन वी
ठीक है,
वेट
कोई
फॉर
बात नहीं। 5 मिनट रुक
5 मिनट
जाएंगे।
वेट कर लेते हैं सर।
हाँ।
ये सर।
अभी मेरा ना ये ब्लूटूथ से कनेक्टेड है, माइक से प्रॉपर आवाज आ रही है।
हाँ, यस सर, क्लियर है।
ओके, ठीक है।
सर पीपीटी भी शेयर करके चेक कर सकते
हाँ,
हैं।
पीपीटी शेयर कर देता हूँ और आपको ईमेल भी भेज दूंगा उसको जिप करके।
जी सर, बिल्कुल
हम्म।
सर। तो आज सर हम फिर डीपीआर वाला टॉपिक ले रहे हैं,
हाँ,
डीपीआर।
आज डीपीआर
ठीक
वाला
है,
करेंगे।
ठीक ठीक है सर।
हाँ, डीपीआर का दो पार्ट में मैंने किया है। एक में जो है वो सिर्फ गाइडलाइंस है और दूसरे में फिर जो उसके लिए प्लानिंग एंड इन्वेस्टिगेशन करना होता है
जी
वो
सर।
है। शेयर हो रहा है।
हाँ यस सर, विजिबल
ओके।
सर। स्लाइड्स मूव करके सर चेक कर सकते हैं आगे पीछे।
हाँ,
हाँ यस सर,
हो रहा है।
हो रहा है सर। ओके, फाइन
ओके।
फाइन सर।
सौरभ, मैंने अभी आपको मेल पे वो जो इंट्रो आप देते हैं ना, तो वो भेजा है।
ओके सर,
एक बार
मैं
एक बार
निकाल
वो,
लेता हूँ जी
हाँ,
सर।
वो रिप्लाई जो जिससे आपने लिंक भेजा था ना, उसी से रिप्लाई भेजा है, उसी का। देखिएगा, एक मिनट। उसी को ब्रीफ करके आप बोल दीजिएगा,
ठीक है
है ना?
सर।
हाँ, दो चीजें इसमें इम्पोर्टेंट हैं। एक तो एडवाइजर फॉर यूपीएससी
यूपीएससी जी सर।
सिलेक्शंस, और दूसरा, अभी आई एम राइट नाउ एडवाइजर इन ईवाई, अर्नस्ट एंड
हाँ,
यंग,
यस यस सर।
इन द फील्ड ऑफ स्ट्रेटेजी एंड ट्रांजैक्शंस, है ना? तो आज लाइट्स कम है इधर, तो शायद दूसरी तरफ बैठना पड़ेगा। चेहरे पे लाइट नहीं है ना?
नहीं,
डार्क हो
ठीक
गया।
ठीक ठीक दिख रहे हैं सर।
ठीक दिख रहा है?
हाँ हाँ सर।
हाँ।
जी सर, ठीक दिख रहे हैं,
अच्छा,
मतलब ऐसा।
मुझे ऐसा यहाँ से ऐसा लग रहा है कि मेरे चेहरे पे लाइट एकदम डार्क है करके।
अच्छा, तो आप अपना स्क्रीन का सर ब्राइटनेस बढ़ा के देख सकते हैं, मे बी
अच्छा
आपका वो स्क्रीन
अच्छा,
का
ओके,
ब्राइटनेस कम होगा।
ठीक ठीक। शुरू करें क्या?
एक मिनट सर, बस ये आपका बायोडाटा तो मिल गया मेरे को सर, बस। ओके, सो गुड मॉर्निंग एवरीवन, वेलकम टू द डे 7 ऑफ द ट्रेनिंग प्रोग्राम। तो सबसे पहले तो मैं रिक्वेस्ट करूंगा सभी से, प्लीज़ अपना आप वीडियो कैमरा ऑन कर लीजिए। हाँ, अपना कैमरा ऑन कर लीजिए प्लीज़ सभी। दो ही लोग हैं अभी तक। हम्म, बाकी लोग भी अपना कैमरा ऑन कर लीजिए। वी आर वेटिंग फॉर यू। So today we are starting the day 7 with the two sessions on guidelines for preparation of detailed project reports in respect of water resources projects. And to deliver these two sessions, we have with us a very eminent faculty, a very expert faculty in this area, Shri Dhirendra Kumar Tiwari sir. Sir retired as Chief Engineer Central Water Commission. Just to briefly introduce sir, Sir has worked more than 35 years in the water resources sector. Sir is currently an advisor to UPSC for selections and also visiting faculty at National Water Academy, Pune. He is a fellow of Institution of Engineers, India, as well as of Indian Water Resources Society. Sir is a certified dam safety professional. He retired as Chief Engineer Central Water Commission in the year 2023. And Sir has served at various very senior levels in Government of India in several fields of water resources, and as such he possesses vast and wide variety of experience, including those dealing with international aspects of water resources cooperation with Nepal, Bangladesh, Bhutan, as well as various interstate matters. Sir has had successful execution of assigned tasks in difficult areas of the Northeast, Farakka Barrage project, as well as in Nepal and Bhutan. Sir has worked in almost all areas of water resources, such as planning, development, execution, monitoring, impact assessment, disaster management, etc. And he has worked extensively on anti-erosion works on River Ganga and bank protection works for Paro Airport in Bhutan. Sir also spearheaded geological and geotechnical investigations for Punat Sanchu project in Bhutan. He has prepared a detailed report on remedial measures for downstream protection of the Chuka Dam in Bhutan, which has been implemented in Tuto. Sir has worked in Nepal as project manager for Saptakoshi Sunkoshi project, and he has also had a very large experience in field of preparation of DPRs for water resources projects. He has also actively worked in flood forecasting and hydrological observations in several basins of the country. He has also been actively involved in monitoring and appraisal of major and medium multi-purpose projects. He has played a crucial role in capacity development and imparting trainings to working and in-surface professionals as well as farmers and general public, as he was also serving as the chief engineer and head of National Water Academy, that is NWA Pune. And also, Sir is currently advisor to UPSC as well as he is advisor to EY, that is Ernst and Young. So with this brief introduction, I welcome Shri Dhirendra Kumar Tiwari sir to this training program. And now I request sir to you may please start the session. Over to you, sir.
Okay, thank you very much, Saurabh, and thank you to National Water Academy also for giving me this opportunity to interact with our young professionals. So good morning, everyone.
Good morning.
Now I am sharing my presentation. The presentation will cover two parts. In the first part, we will talk about guidelines for preparation of a DPR, and in the second part, that is after 11:30 onwards, we will be dwelling upon the planning and investigation. What are the different kinds of investigations that are required to be done for preparation of a detailed project report. So starting with the first part, let me share my presentation. So is the slide visible to all?
Yes,
Guidelines
sir.
Guidelines for preparation of DPRs for water resources projects. So what is a DPR and why it is required? So DPR is a detailed document, and it is a document which facilitates by which we examine techno-economic viability, and all on the basis of that we take an investment decision. What does this mean? We will further deal with it. So it is a well prepared document in a standard format. That standard has been laid down by CWC by means of different guidelines. We will be seeing those guidelines. And this document is based on reliable data. What is important here to note is reliable. Means your data collection must be from reliable sources, and that data must be reliable. Different kinds of data: hydrological data, topographical survey data, geological data, then construction material, etc. Then how do we reach, that is access and infrastructure data. So different kind. Then financial data also, because ultimately we will have to take a decision for investment. So financial decisions are also required to be made. And this reliable data, one of the means to collect this reliable data is that we should carry out investigations. So we should have done adequate investigations, and the data collected on that goes into preparation of that document, which is called a detailed project report. Then one other aspect of DPR is that it contains comprehensive studies on various techno-economic studies. What are those comprehensive studies? For example, say hydrological simulations, then design flood studies, then irrigation planning studies, geological assessments. So there are seismic assessments or geophysical studies. So there are different types of studies which are required to be carried out, say power potential studies. So there are different types of studies that we carry out as part of preparation of a detailed project report, that is DPR. So now DPR now you got the idea that DPR guidelines which have been laid down by Central Water Commission. They facilitate formulation of project reports, and they also facilitate scrutiny of prepared DPRs. In CWC, we have two categories of functions related to the DPR. Which are these two? One is that you may be receiving the DPR in the either in the field office, means director appraisal, or you may be receiving them in the head office. So for examination of the DPR. So one is related with the examination of DPR. So there may be certain interstate rivers, interstate issues involved. There may be certain disputes. So these kinds of DPRs frequently come to Central Water Commission. And then we may be, another category is where we are required to prepare the DPR. So we may be required to prepare the DPR also, especially in the northeastern region for Jammu and Kashmir, then Jharkhand, and recently we have also carried out some investigations in Ayodhya region for Ayodhya barrage. So what is the guidelines? Guidelines provide a ready and standardized template to facilitate both these functions. Once we have a standardized template, it becomes easier for us to collect the required data, to carry out the comprehensive studies that we discussed earlier, and then prepare the DPR in a standard format, and also to see if the DPR which has been sent for our examination, whether the first thing is whether it has been prepared according to standard format or not. So that standard format also provides us with a checklist. So why detailed project report is required? So now you understand that DPR, what does it do? It establishes the need of the project. Then it presents a careful analysis of historical and field data. It presents design of various components. It may not be very detailed design, but preliminary designs are included. It assesses environmental impacts also, and it includes estimated costs, benefit and cost benefit ratio, break-even ratio, and also viability of the project. So on the basis of the DPR, various clearances to construct the projects are given and funds are mobilized. So it is a very important document. So what is, again, let us see what is DPR. DPR provides a snapshot view of concept, from concept to commissioning. It lays down a clear-cut scope of statement. In our earlier lectures, we have discussed about the importance of scope when we go for preparation of estimates. So this DPR gives us a very clear-cut scope statement, what is included and what is not included. On the basis of the techno-economic viability studies, we take investment decisions and provide a base for approval of plans and designs, and ultimately it paves a way for project planning, implementation, and scheduling. So what are the important guidelines for preparation of DPR? These are some of the important guidelines. The most important being this one: guidelines for preparation of DPR of irrigation and multipurpose project, prepared by CWC in 1980. Now it has been revised in 2010. Here it is written here, see my cursor, guidelines for preparation of DPR of irrigation and multipurpose projects, prepared by CWC 2010. Then there are guidelines for preparation of project estimates. So the estimates, the DPR contains an estimates volume, in which we work out the estimated cost of the project. So for that, we follow the guidelines issued by CWC in 1997, and that is a very important guideline. Then for hydroelectric schemes and their acceptance and examination, There is a guideline issued by CEA, Central Electricity Authority, in 2015. Then there is also in IS code 4877/1960 guide for preparation of estimate for river valley projects. Specifically, especially it is used for allocation of costs. In addition to this, there are number of IS standards for different components of DPR, different components of the projects and cost estimates. A list of those IS codes will be given at the end of this presentation. So this is the most important guideline which we will be dealing with. So this is the 1980. It was first issued in 1980 and subsequently revised in 2010. So Government of India, Ministry of Water Resources, guidelines for preparation of detailed project report of irrigation multi-purpose projects. This is the first page of cover page of that guide, those guidelines. Now this guideline has 4 parts. One is irrigation and multi-purpose projects. So obviously the title conveys that, but then there are flood management schemes. These are also in how to prepare DPRs for them is also included in these guidelines. Then several of the irrigation projects have fallen into or need extensive repairs, etc., because they are quite old. So there is modernization of irrigation projects. So for modernization, what will be the type of DPR? This is also included in these guidelines. And then one part deals with the command area development. Irrigation and multi-purpose projects, you already know there are three classifications. If it is less than 2000 hectare, this is called minor project from irrigation point of view. And if the command area is 2000 to 10,000 hectare, it is medium. And if it exceeds 10,000 hectare, then it is a major project. The format and content may vary according to the type of the project. So we will be dealing mainly with the irrigation and multi-purpose projects. So what does this so DPR, the process of DPR is like this. You first select a site, then carry out survey and investigation. Based on those survey and investigation, there is a detailed planning. So you plan the layout, what are the different components of the project, power, irrigation, drinking water, flood control, irrigation, all other benefits are planned. Then model study and design, sample designs are done, and then economic evaluation. So estimated cost and benefit, and then conclusion, whether it is techno-economically viable or not. Techno-economically means what? It should be technically viable and also it should be economically viable. So benefit cost ratio should be more than 1. And if it is a power project, then break even period should not be much, very, very long. Maybe 3 years, 4 years, 5 years. It should, the cost should break even. It has hanged. It is not moving forward. Why? Now it has moved. So detailed project, say we have one detailed project report. It will have 5 main volumes. Preceded by sections on checklist and salient features. As I told you that there is a standard format of preparation of DPR. So the guidelines provides these standards, these standard formats. So first part of the DPR is checklist. Then salient features, there is some spelling mistake, salient features of the project. Then volume 0 is the executive summary of the project. Volume 1 deals with the project engineering, Volume 2 with cost estimates, Volume 3 contains drawings, and Volume 4 contains appendices. Appendices includes all the sources that you are using for your project engineering volume as well as cost estimate volume. So nothing, any data that you are using for preparation of DPR can be verified, can be seen from the appendices that you have used, which source for that data, and accordingly the decision-making authority can assess whether that data is reliable or not. So what is executive summary? It deals with brief introduction of the project and contains salient features with brief summary of all the chapters to provide an overview of any detailed report. Because going through the detailed project report will require a lot of time. So the executive summary gives you, in brief period of time, you get the overall view or an overview of your project. Then project volume 1 contains project engineering. So this is the core of the DPR. It contains chapters on every aspect of the project planning: technical, financial, sociological, environmental, etc. Depending on number of chapters and details included, it may be in multiple volumes, like volume 1A, volume 1B, volume 1C, depending upon the quantum of studies required. This includes introduction, then there will be a chapter on topographical survey, then there will be a chapter on geological investigations, then geotechnical investigations, and construction material survey, access and infrastructure survey, power potential studies, and hydromechanical parts and hydroelectric parts. Then there will be construction planning. Then there will be cost estimate. Cost estimate will be in a different volume, but summary will be here when we give the chapter for economic evaluation of the project, and then summary. So volume 2 contains the cost estimate. So we will be dealing, or you must have been told about different heads in which estimates are prepared. And after pre-construction surveys, we prepare the construction drawings, and then construction takes place according to the construction drawings. So here in volume 3, drawings are DPR level drawings. So this includes all civil drawings, hydromechanical drawings, and for all relevant components of the project.
सर
It includes
सॉरी टू इंटरप्ट सर, बट वी लॉस्ट यू. अभी आपका ना कनेक्शन शायद इंटरप्ट हुआ है, सो आपका स्क्रीन शेयरिंग चला गया है सर. सो यू
ओके, I will
शेयर
resume.
अगेन.
ओके, है अभी visible?
हाँ, अभी विजिबल है सर.
Okay, okay.
ओके सर.
So volume 3 is drawings. So these are DPR level drawings. So it includes drawings for all the important components of the project: civil, hydromechanical, electrical, and all other areas. Topographical survey drawings, reservoir area survey, command area survey, and other miscellaneous drawings. Then appendices. As I told you, whatever studies are required, those original studies, copies of those original studies are enclosed in appendices. Then all the geological investigations carried out, those geological reports, bore logs, etc. Then design memoranda, they are included. Material testing reports are included. Actually, construction material survey chapter is included in project engineering, but the tests which are carried out on the material, those test results are included in this appendices volume. Then whatever hydrometeorological data that we are using for assessing our water availability or design flood or sedimentation studies is given here. Drilling and drifting data is given. then and all other inputs, say for example, for working out benefit cost ratios of an irrigation project, we need crop data. What are the different types of crops? What is the cropping pattern? What is the market rate? All these are included in appendices. So I will just give you an example of a detailed project report. Can't specify. Okay, I will search and then I will show you subsequently. Let us move ahead. So here we finished the first part, and I think in just half an hour I have given you the guidelines. So I will now show you that particular DPR, because that DPR I was not able to show you how it is made. It was a small DPR, and it is. DPR investigations. Now this is jumbled up here. Output is not coming correctly on this. I will close down this one. No, it is not showing like that. But from here you can see, though it is not showing correctly on this browser, I think there is some issue. On this browser, it is actually it is an HTML document, but it is not showing it correct in a proper format. The DPR contains these things: preface, then forward, and whatever you want to write. Then volume 0 is executive summary, then project engineering, cost estimates, appendices, and drawings. So this is your executive summary report. You see, these are the different chapters in executive engineering. First is salient features, introduction, field investigation. So whatever is included in your DPR, your volume 0, that is executive summary, includes all those in very brief. So, but here you see the executive summary itself is quite big, that is 66 pages. So what does it mean? That executive summary is not a summary of 1 or 2 pages. It should give you a whole view of the project in brief. So because there are different components, different types of studies, all must be mentioned, and therefore, but in brief, all must be mentioned but in brief, and that is how this is called uh, this is called a executive summary. Oh, sorry, I disconnected probably. डिस्कनेक्ट हो गया क्या? Just a minute, I will again connect.
No, sir, you are there. You are there.
अच्छा, विजिबल है मेरे पास से चला गया,
visible.
ये कहाँ गया मुझे ही नहीं दिख रहा.
Visible.
Just a minute, हाँ. Okay, you are sharing the screen और वो वेबएक्स का कहाँ चला गया? I will just stop and then restart, right? Because
Okay, sir. Okay, sir.
okay. Now here I am. Okay, so we have dealt with the first part wherein the guidelines have been given, and now we will briefly cover the different types of planning and investigations that are required to be carried out as part of our preparation of DPR. So is my screen visible?
नहीं सर, अभी तो नहीं है।
No, sir.
अच्छा, अभी नहीं है। ओके, क्या इशू हो गया है? मैं शेयर करता हूँ फिर से,
हाँ, फिर
शायद
से शेयर कीजिए।
हाँ, फिर से शेयर करता हूँ। अभी विजिबल है?
हाँ, यस सर।
Okay. So after going through having a brief about what are the different guidelines, now how these different guidelines are used for planning, investigation and formulation of river valley projects. So what do we mean by planning? So as you already know, river valley projects typically include, there are different types of projects: barrage, headworks, canal systems, then hydropower, run of the river schemes, dams, intakes, HRT. These are the different types of components. In flood protection schemes, there are flood embankments, powerhouses, drainage channel, and multi-purpose projects include all these kinds of things. So what are different stages of investigation or doing studies: pre-feasibility, feasibility, then detailed investigation, that is DPR stage, and then at the construction stage, which can be divided into pre-construction and construction. So what is planning? So this is the standard definition of planning from the textbook on water resources systems given by Lenslee and Franzini. The orderly consideration of a project from the original statement of purpose through the evaluation of alternatives to the final decision on a course of action. What does it mean? Let us understand this. So planning starts from a purpose. Say for example, there is an area which is a drought prone area. People need water for drinking, people also need water for irrigation, and also they are as yet, suppose, let us imagine they are not yet connected to the grid, so they also need some electricity supply also. So what is our original statement of purpose? We need a water, but there are sources of water nearby. So our primary purpose or original purpose is to construct a multi-purpose water resources project which will serve the purposes of drinking water, irrigation and hydropower to a distinct area having a certain population, having a certain habitation of people as well as cattle and flora, that is plants and species. So now how this is orderly consideration of a project. So now we have got the purpose statement. Now we will move ahead gradually. How to realize that? So we first go to the site, find out what are the different alternatives available to us. And then for those different alternatives, we carry out systematic studies. And after those systematic studies, every alternative is evaluated and final decision is based on the best alternative which serves our purpose in an optimum way. So this is the planning of a water resources project. So basis to proceed with an or abandon a proposed project depends upon this. So detailed project report is a very important part of water resources project planning. On the basis of the planning, this detailed orderly consideration, we can either accept a proposed project for investment or we can reject it. So we must remember that each water resources project is unique in physical and economic settings. Means what? No two water resources projects are the same. They may be similar, but that's all. Every water resources project is unique and therefore no single fixed approach to planning. Rather, engineering judgment plays the most crucial role in selection of the method or approach. So each decision or judgment must be supported by quantitative analysis. So it is not your subjective judgment, but engineering judgment means your judgment is based on data and its analysis in a quantitative manner. For example, benefit cost ratio gives us a statistic, which is benefit upon cost that must be greater than 1. So it is a quantitative, a static which gives us an idea of about economic viability of that project. So what are different levels of planning? You see, let us go from whole to the part. First is the national plan. So we earlier had 5-year plans, though we don't have now those 5-year plans, but more or less our economy moves on the level of planning only. Niti Aayog provides the planning directions. Then regional planning, then there are state level planning, and ultimately at the last, project level planning. So we will be dealing with the project level planning. What are important considerations in planning? Number one is economics, and at the same time social aspects of water resources engineering. Economics, you know, what is to be considered. Our funds are limited. Then cost, whatever we are investing must be commensurate with benefits. Future projections, say life of the project is 50 to 100 years. So what is going to be the development in that particular area? So that project should be able to fulfill the demands that may come up after 50 to 100 years. Another is available technologies and future development in technology. You must have heard about nowadays data centers. Data centers are huge guzzlers of water. Their water demand is very, very, very high. You cannot imagine. When tens of thousands of liters will be required to cool their servers and machines. So depending upon the available technologies and further development in that field, then economic analysis we carry out to determine the best alternative that clearly demonstrates that cost is sufficiently less than expected benefits to warrant investment. Means what? That our costs are less, benefits are more. So our benefit cost ratio is greater than 1. So we are deriving more benefits in comparison to cost in a period of 50 to 100 years. That is the life of the project. And what are the different social aspects of water resources engineering? You see, every water resources project is a unique, as I told you. So there are different types of there may be different kinds of social aspects. There may in some projects tribal population may be affected. In some by some water resources projects there may be tribal population as well as wildlife. There may be protected areas, there may be sanctuaries, so there may be protected forests, and even if they are not there, but then there may be mass uh, submergence of trees and forests, and also people, a large population need to be rehabilitated. So it is engineers responsibility to consider all those probabilities in public interest. तो हमारी क्या पोजीशन होना चाहिए जब ऐसे सोशल एस्पेक्ट इन्वॉल्व होते हैं? तो our decision, our considerations should not be affected by political or emotional involvement. जो एक्टिविस्ट का उत्साह होता है, हमें एक्टिविस्ट का उत्साह अवॉइड करना होगा. We must be objective. fair and impartial. We are not activists for water resources projects. We are just a stakeholder in the economic development of the country by harnessing our water resources. But we are not water resources. We are not to act as water resources activists, because then in the people's eyes your position will become compromised. So for the people whom you are going to convince, your position must be impartial and fair. So you should not be politically inclined, you should not be emotional about your project, you should avoid activist zeal, and your attitude, your position must be ethical, objective and in public interest. Public interest means कि जो larger good के लिए है, जो जनरल लोगों के भलाई के लिए है, वही हमारा पोजीशन होना चाहिए. So now this is the summary of how we move in our planning process. One is say political incentive. अपने यहाँ बिना किसी political push के कोई भी project आगे move नहीं कर सकता है. Then you go to the site, you define different alternatives. Technical feasibility, you investigate each alternative. उनकी technical feasibility देखते हैं. Then what is social and environmental acceptability? Then financial feasibility, and then final decision is based on other factors, availability of funds, acceptability to public, etc. So these are different factors involved in planning. So what are different phases of planning and investigations? जैसा अभी हमने देखा, एक तो planning process है. ये planning process national level से होते हुए हमारे project level तक आई. Then different factors which are going to affect our planning and ultimate decision of the project. Now suppose we will try to think over in engineering terms what we are required to do in planning and investigation. So first is reconnaissance surveys. So surveys at broad level, then pre-feasibility and feasibility surveys you are required to do, preliminary investigations, then detailed investigations. So there is, what is the difference? There is difference of scale in these different types of surveys, and there is also difference in accuracy. When we will be dealing with the preparation of estimates, we will be coming across these. What are the different types of accuracies that you are required? What are the different types of scales that is required for different types of investigations? So once we reach the detailed investigations, up to by feasibility studies, we can close in on certain alternatives. Say for example, two alternatives look feasible to us. Now go for preliminary investigations for these two. Say these three investigations look feasible to you, then you go for preliminary investigation for these three, means you go for certain finer investigations. Then from three you have now come to two alternatives. So then you go for detailed investigations of these two alternatives. You go for design engineering, then you go for estimating and costing, and then comes the engineering economic analysis, that is benefit versus cost analysis. Then you will decide which one of the alternative is to be recommended, and based on that people may take it. So then your detailed project report is ready. Then before construction, again investigations are carried out just to assess if there is a change in situation in the field. These are called pre-construction investigations. So broad types of investigations, survey investigations में हम क्या क्या करते हैं? Desktop studies, then topographical survey, hydrological and meteorological survey, geological and geophysical survey, geotechnical and soil survey. Geotechnical is from the engineering point of view, and soil survey is from the point of view of irrigation benefits, so irrigability, etc. Then there are seismic studies, then construction material survey, access and infrastructure survey, command area survey, and drainage survey. These are main surveys which are required to be carried out. So you see, one of this is the Musto type benchmark. This is a very specific design. When we establish a benchmark, a musto type benchmark we prepare, and this design has been standardized. Remember that water level is not written over your benchmark. That is maintained in a separate registers. So permanent benchmarks, there are GTS, which are called GTS benchmarks. These are to be obtained from the Survey of India department, and from there you carry out your own surveys and fix up your own benchmarks, which may also be a type of permanent benchmarks, and then from there you carry out different temporary benchmarks for your survey purposes. This design has been standardized for permanent benchmarks, which is also called musto type benchmarks, MTBM. So coming to the topographical surveys, topo means what? A place or location. So what we survey in this, the geographical positions both on plan and elevation of the natural and artificial features of an area, and the purpose of delineating them into useful information. For example, contour lines, terrain identification, delineation of river or water body. You have already carried out during your graduation days all these surveys. So what are the commonly used methods? Plane table survey. Then nowadays we are also using GPS. Then using total stations. Then we use differential GPS. Nowadays drone surveying has become very popular, and then ultimately remote sensing. So these are the using auto level, that is plane surveying. This is the most commonly used equipment in our field. You already know, you must have carried out how to use these auto levels. So this is the leveling principle. I think I need not go in detail of this. Means backside, foresight, how to find out the level at level at particular place in connection with your temporary benchmark. And temporary benchmark is in turn connected to the permanent benchmark, which may be either your musto type benchmark or a GTS benchmark. What is full form of GTS? Great Triangulation Survey, that was carried out by Survey of India, and they have created permanent GTS benchmarks at several places. So from there we obtain the information from Survey of India, we carry out surveys and fix up our own benchmarks for the project purposes. Then total station. We will not go into the details of this because this is not required at this stage. Then there are differential GPS. Differential GPS means there are two kinds of your GPS instruments. One is rover and one is fixed. So based on these two, one is this, one is this roving receiver, and another is this GPS receiver. So based on these two, we find out the errors and reduce those errors by means of different methodologies. Then drone surveys. So you already know about these things. And then through the drone survey, our cost of finding out some short contour interval surveys has reduced drastically. Earlier it was LiDAR or laser based altimetry, which was run through planes and smaller planes, but nowadays drones can do it, and they can do it in shorter period of time and at much lesser cost. Remote sensing, this is based on the satellite imagery. So broad features of the land can be assessed through the use of remote sensing or photogrammetric surveying. Now our guidelines lay down what are the different types of surveys and what scale should be used. For example, this is given in the guidelines of 2010, and in the annexer portion you will find these scales given. So for L section, for cross section, upstream, downstream, they have been laid out. Say horizontal scale is 1:10,000 and vertical scale is 1:100. For what? For L section, upstream of the say proposed dam axis. Now, what are the remarks? Leveling at 50-meter or less interval along the fair weather deep channel. So leveling आपको जो लेना है, levels it should be maximum 50 meters. Similarly, for cross sections, the horizontal scale is given 1:2000, vertical scale is given 1:100, and then again leveling max is 50 meters. So in a similar fashion, for different types of surveys, different scales have been given and different contour intervals are given. What are those components? Say, for example, reservoir, you can see on your screen, reservoir, dam and dike, barrage and weir, canal water conductor system, then canal structures. There are additional powerhouse, switchyard, surf shaft, then plant and colony, tunnels and edits, pen stocks. These are given in our guidelines, and we have to follow these guidelines when we are going for topographical survey for detailed project report preparation of any project. Now we come to the hydrometeorological data. Now we are reaching 11 o'clock. So just after 5 minutes, after finishing this hydrometeorological data collection, we will take a break and then we will reassemble at 11:30 and then we will finish subsequently. So coming to the hydrometeorological data connection, what are the types of data required? Rainfall data, that is daily rainfall as well as hourly rainfall data. How do we collect it? Daily rainfall data is collected through the standard rain gauges, which are also called ordinary rain gauges, but the proper name is standard rain gauges. These have been standardized by IMD and also included in various IS codes. Then there are hourly rainfall data also, which is collected by different types of instruments. One which is being used in Central Water Commission at several places is, in our all telemetry systems, is tipping bucket rain gauge, TBRG. Then meteorological data, we are collecting temperature, relative humidity, evaporation, then solar radiation, wind speed and direction, then gauge and discharge data. Now remember, there is one is the daily gauge and discharge, which we carry out at 8 a.m. every day. Then there are hourly gauges. Then there is 3 times gauges. During monsoon period, that is say from 15th of from the 1st of June to 15th of November, we are carrying out gauge observations every hour, 24/7. Every hour we are reading the gauges at this site. At some of the places, we also take 3 times gauges, which are less important sites. Now, so here you must differentiate between maximum observed discharge and peak discharge. What is maximum observed discharge? Maximum observed discharge is that discharge which is observed at 8 a.m. During 8 a.m. observation, whatever maximum has occurred, that is the maximum discharge data that is observed. And what is the peak discharge data? Peak discharge data is a computed value which is calculated from the peak of the gauge, because peak of the gauge it is not necessary that it may occur at the time of daily gauge discharge observations. Your peak gauge may occur even at night at 2 o'clock. It may occur at 4 p.m. in the day, at any time, at any random time. So it must get it will be recorded through hourly gauges which are observed 24/7. So that peak gauge multiplied by your stage discharge curve equation, then you will find out the discharge corresponding to that peak gauge. That is your peak discharge, which is used for flood frequency analysis. So this is a very important distinction that you must understand at this point. Then there are sediment data, bed load data, and suspended sediment data. Why these data are required? First is water availability. wherever you are planning your project, how much water is available. So for that, you have to have a flow series, means you have to have a long series of data, continuous series of data of discharges. Then you carry out simulation. For simulation, the guidelines provide that you must have 30-year data, but sometime many time 30-year data is not available for new project conceptions. Then what we do, whatever data is available, say for example 5-year data is available, then based on the statistical characteristic of that 5-year data, we extend the series say to 30 years and then carry out the simulation. Then there are rainfall runoff correlation we find out, so that we also know what, if this is the rainfall, then what is going to be the runoff. So then we come to the design flood studies. For design flood studies, there is one IS code. It is also included in the guidelines. So there are mainly three types of design floods. One is PMF, that is probable maximum flood. Another is standard project flood, and one is 100-year return period flood. 100-year or 50-year return period flood is used for design of barrage. SPF and PMF are used for dams depending upon their height and storage behind them. So for calculation of these design flood studies, we need design storm, which is normally given by IMD, or even in CWC, we find out on our own, because now PMP atlases are available everywhere. We derive the unit hydrograph based on hydrometeorological data that we have, and then we carry out what is the first we carry out what is probable maximum storm. Then based on that, we determine what is probable maximum flood or standard project flood. So you just for your preliminary understanding purposes, you can assume that PMF is the probable maximum flood, means what? It is the maximum flood that can occur. This is calculated by maximization of all the factors that go into calculations. Means whatever can be maximum, whatever maximum factor will occur, that will lead to the maximum rainfall. So based on that rainfall, whatever catchment response in the form of hydrograph will come, that is the probable maximum hydrograph, and the peak of that is probable maximum flood. Then we carry out sediment studies based on bed load data and suspended sediment data. What is the rate of sedimentation? So because as the reservoir will get silted, its zero elevation will come up above and above. So your outlets must be fixed at such a level so that it doesn't get blocked by siltation. So after 50 year, what will be the level of siltation? After 100 years, what will be the level of siltation? And after the siltation has taken place, what is the revised area elevation capacity curves? So these are parts of sediment studies. Then we carry out lake evaporation studies and also potential evapotranspiration. So for simulation purposes, these are the different classification given by our guidelines. So what is the type of input required, and what is the classification of the project by according to the use and according to the storage by C, B and A. These are the classification of the project from two considerations. And what are the types of inputs required for different types? It is given in C. That is C1 for simulation studies and C2 is for studies other than simulation. So I will not go into the each one, that because otherwise it will take 6 hours lecture. So just you know that it is given here. So whenever you go for carrying out preparing hydrological inputs for any study, then you refer to these guidelines. Here it says, what are the types? If your storage is of type A1 and A2 and the project is all except B2, then what are the hydrological inputs required? These are given in our guidelines. I am repeating, these are given in our guidelines. You need not remember them, but whenever you must know where these are given. You need not learn them by rote. but then you understand and you know that yes, these are given in your guidelines, you refer to them whenever required. So with this, our hydrometeorological data and in studies is finished, and then we take a break. 11, it is 11:05. So by 11:30, we will reassemble and we will finish the remaining planning and investigation required for detailed project report. So we'll take a break now. Okay.
Okay, sir.
Okay. Shall we restart now?
Yes, sir. You,
Okay. So once again, I am sharing my presentation. Okay, so we were here. We had finished uh, two important investigations for preparation of detailed project report, that is topographical survey, and another was hydrometeorological data collection. You can also call it hydrometeorological observations or hydrometeorological surveys and studies required. For example, water availability studies, then design flood studies, and third, sedimentation studies. In addition, there are evaporation studies also required, but mainly three studies are required. So coming to the geological and geotechnical investigations, why we carry it out? First of all, to evaluate the groundwater conditions, engineering properties of the overburden and rocks. First, let us find what is the depth of the overburden and at what depth rock is available. And if rock is available, then what is the kind of rock? What are its engineering properties? That is a strength, fracture, etc. Then stability of slopes adjacent to the excavations, landslides, rock falls and avalanches, groutability of the geological medium, and then liquefaction and settlement aspects. So geology is, for most of the dams, geology is the guiding factor. How? You see, for planning, what is the type of project or a scheme? If there is no rock available at a reasonable depth, then a concrete gravity dam is ruled out. So for this was just an example. So it is very important to know what is the kind of geology. Then it will also decide the type and dimension of the structure, then deciding locations and designs of major structures. For example, if there is a good underground rock available, then we may consider if a powerhouse, underground powerhouse can be constructed. Then for optimization of layouts, whichever layout gives us the best geological stability, deciding construction and excavation methodology depending upon what is the kind of rock joints, what is the slope of joints, etc. Deciding protection and stabilization measures, availability of construction material, and monitoring of performance of the structure. So what are major geological problems? This is the most important thing that you must understand: weak and weathered rock mass. Rock may be there, but it may be weak or weathered. Weathered means because of the impact of environmental factors such as heat, alternating heating and drawing, then water coming over it, and then again drawing, then it gets broken and gradually it becomes weak because of the action of the weather components. So that is weathered rock mass. Loose and uncompact soil or overburden. If the overburden is there and if it is a very compact clay, then it will behave differently than an uncompact soil or silt. So then weak and adversely oriented discontinuities, joints, shears, folds, and faults. These are the kinds of discontinuities in rocks. Say, for example, if there is a joint which is sloping downwards, then water will go downwards, further downwards. So that is not suitable for a reservoir. Then stress patterns in the rock strata. When we carry out small tunnels called drifts and take samples and carry out in situ testing, then we come to know what are the stress patterns in the rock strata. Then how is the water moving through the subsurface stratum, that is geological formations, overburden or rock masses. Say for example, if there is a layer of limestone and water flows through it, then gradually that limestone will get dissolved, and then there will be settlement taking place from higher up for to fill up the vacuum created by the dissolved limestone. So these are the things which may happen. So let us see what are the different types of failures that occur. Say for example, sinking of ground. You just go on seeing the examples. Now here a failure of a dam. This was the dam, Tiwari Dam of Maharashtra. Then again here the failures of the different types of dams, etc. Now you see here failure along abutments. These are all major examples of geological failures due to geological factors, or failure due to not undertaking proper geological investigations. These are problems faced in tunnel. These are the problems. See, in this tunnel on your right, water is coming so much in such a large quantity. There is just like a small stream flowing through the tunnel. Now in the first, there has been a rock fall, and in the bottom one, the entire excess has been blocked. So these are the problems of dam from the point of view of dam stability. See, trees and brush, then rodent activities, seepage at abutment and contacts, or if there are different types, if it is not a monolithic, then there are different joints, and from that point water starts seeping. Then cracking, low area in crest of dam, then concrete failure. Piping means if there is a less exit gradient, then water creates erodes the material from inside the earthen embankment, and a pipe type creation happens, and then dam fails. So these are stability failures, cracking, piping, seepage at abutment contact. You see slump, erosion at outlet, scour level. These are the due to damages in the embankment due to the movement of water. So there will be embankment failure. There will also be failure of the foundation. So these are the therefore geological investigations are to be carried out in great detail. What are those geological investigation? Collection of site, topographical and geomorphological data, that is terrain conditions, geological mapping on different scales. Geologists carry out these geological mappings. Then delineation of depth of weathered, weak rock mass, overburden, and geophysical survey, pitting, trenching, drilling exploratory boreholes, exploratory drifting, etc. Then delineation and engineering characterization of rock discontinuities, including geometric properties. So these are different geological investigations that we carry out to find out what lies beneath the surface. So by say geophysical survey, which is non-destructive method, by means of, we will see further ahead. Pitting, we create a small pit or trench and then observe what is the kind of subsurface depth, subsurface soil or rock. Then drilling exploratory boreholes. Normally we take out cores, and then by observing those cores and also subjecting those cores to different geological tests. Similarly, exploratory drifting. In drift is a small tunnel of very small size, say 1.2 meter or 1.5 meter, is created of say a small length, say 10 meter, 15 meter, near abutment or near the dam axis, and then we carry out certain tests on that. So these tests are carried out for delineation, means what is the extent and engineering properties of those rock masses, and preparation of surface geological maps and geological sections. Gathering information on groundwater regimes, water table, what is the water table, piezometric head, its distribution in the subsurface strata and rock mass, permeability of the rock mass. When we carry out drilling, we also carry out permeability tests. Gathering information on stress patterns of rock mass characterization and estimation of engineering values, Q and RMR. You simply remember Q represents a kind of empirical factor which represents different qualities of rocks. Collection of relevant data on rock mass strength, etc. So these are then ultimately seismotectonic studies. So these are the preliminary investigations that we are required to carry out. See, this is a geological section along the dam axis. So this gives what is the kind of slopes of, what are different types of rocks, what is their slopes, what are the joints, and how the joints are sloping. This is just an example to show you. See here on a satellite image, this shows different components. So where a layout of a project, so where and how you need to carry out investigations. So detailed investigation, geological mapping का scale क्या होगा, 1:500 or 1:1000. Then exploratory pitting, trenching, drilling, drifting, geophysical investigations, then preparation of geological sections, stripping so as to know what is where the abutments and what are the kind of abutments available, whether abutments are available or not, and then let us see what are the geological exploration. So seismic refraction method is a type of geophysical investigation. What we do here, generally there are two types of seismic waves, P waves and S waves. So we record, what we carry out, there is a small say impact created in the on the surface, and then there are geophones. Geophones are the instruments which have sensors which record the P wave, that is the horizontal movement of the wave. So these are the recorded by these geophones. I will show you a picture of that. See here. Now here an impact is being created, and these are different geophones installed here, receivers. So different from here to here, what is the distance and how much time it has taken to travel to these geophones. And so by this method, we find out what is the velocity of the P wave and what is the magnitude and also the period, that is a time period of the wave. So this is one of the methods. You see here another way of creating an impact is a small implosion created in the subsurface strata, and then recording the sensors record it. Now let us go for geological boreholes. How do we create boreholes? This is an example of drilling machine, simplified sketch. There is a casing. Within the casing, there is a drilling bit. So this is the drill pipe. Inside that, this is the drilling bit is here. So as drilling bit goes down, the rock core gets inside here. This is called sampler. So that rock sample is collected here and then it is taken out and then stored in these core boxes. These are different cores. For example, see this core numbering is given E5, and here we also write the from where to where. This is a kind of bore log also, means from this depth to this depth, and from this depth to this depth. See my cursor where it is moving. So for example, this is 68, so this is the length. So RL at this point RL at this point, RL at this point, RL at this point. So in this way, we create a bore log of the drill hole. So the longer the core, the better is the rock, because it says that with the action of the drill bit, the rock is not getting crushed, rather it is getting extracted as a whole mass. So that indicates a better solid mass of rock. So type of length, so the length of the rock core itself indicates the quality of rock mass. But then here see a different color, here a different color. So with the observation of color, with the observation of texture, then permeability, then other types of tests, for example, fracture test, crushing strength test, compressive strength test, all these tests are carried out on these core boxes. So how is the core boxes prepared? So sorry, cores are prepared for test. There are IS codes 9179, and then what should be the dia, and all these things have been specified. You need to refer to this IS code 9179 of 1979. Core specimens of 54 dia are drilled out from rock boulders and testing purposes. You see, geological and geotechnical, this drilling is being carried out here in the river bed. When the river is all, there is water also. Here it is being done on the banks. These are on this left side. This is a diamond core bit. So these are industrial diamonds, because diamond is the hardest available material. So there are small pieces of diamonds embedded in this steel. So then with this, the rock is cut. You see here, this is an example of how these cores are being stored. So Ooch multi-purpose project, river bed hole. So river bed hole, bore drill hole number, then what are its coordinates, then collar elevation, ground elevation, core box number, and run means 4200 to 42.00 to 46.50. So 4.5 meter is the runoff. This is called core log. These are different types of diamond bits. So see here, it is more or less used. So this is for cutting. This is after it has been used. This is another example of first a platform is erected, then drilling machine is actually in the field. Drill machine is so heavy a machine that it cannot be carried out as a whole. So what we do is normally we disassemble it, and at the site we reassemble it by creating a platform and then reassembling it. So this is the kind of again examples of cores. You see, one single core means it is indicating a very good quality rock. So here the you see drilling is being carried out in the rocks itself. Here small pieces of rocks has come. So it means that in this the rock mass is of less strength than the earlier what we saw. Then we come to the exploratory drifts. I told you that exploratory drifts are small tunnels. And in this tunnel, these offer observation by the geologist, observation by the engineer, so that they can have an observation of the rock, actual observation of the rock, how it looks like inside. And then they can carry out different types of rock mechanic testing, for example uniaxial jacking test, plate load test, etc. Then direct shear test to determine shear parameters of concrete rock and rock interface. You see, this is the kind of example where exploratory drifts are being created. This was done in Bhutan, and this portion, you see my cursor, this portion is providing the access for opening the portal. Here you see the rock mass is there. Here it is a portal is being opened. After we reached there, we found that there are small cracks here. So what we did here two rock anchors, so that these cracks do not move further. And then we started work on the rock mass to open a portal. See here, this is the entrance portal to the drift. This has been, this was done by departmentally by CWC people in Bhutan by Bhutan Investigation Division, and this was done when I was posted there. This is for Puna Sangchu hydroelectric project, that was Puna Sangchu 1. So this was the edit that we, this is the drift that we had created. This is the finally when we left the drift. So we provided some support here also, because here at this place there were certain cracks looking. So we provided steel supports and then concrete slabs, prefabricated beams were provided here, so that the portal doesn't, rock mass doesn't fall out here and portal remains stable. So with this, we finish the geological investigations. Now, another important survey is construction material survey. This is one separate chapter included in detailed project reports. And as you can expect, there are huge quantities of construction material required when we go for construction of a dam. So what soils and land location with different types of soils are required, where it is located, how far, what are the borrow areas, what type of soil is available, what is its quantities, what are its properties, then rock masses are required, then sand. So nowadays sand is a very precious commodity. So whether natural sand will be used or crushed sand will be used, this is to be decided, and in how much, if rock is available for quarrying for different types of aggregates, coarse aggregates, fine aggregates, and also for sand. Then other materials are bricks, tiles, pozzolana, cement, limestone, steel, etc. So these are the things that we carry out. So what are the three important parameters that we find out? First is quality, that is being after they are tested as per BIS codes. And what is the available quantities available of different types of material, where are the quarries located, because the distance of quarry is an important economic consideration in estimating. And then what is the assessment of what is the quantities available in those quarries. Then what are the leads? So leads should be economical. For canals, the materials required are sand, coarse and fine aggregates, bricks and cement and water. So these are the different types of IS codes, IS 383, then IS 2386. So specification for coarse and fine aggregate for natural source of concrete. Then standard methods of test are given in IS 236, and for sampling of aggregate, reference may be made of IS 2430-1969. Coarse aggregate. So coarse aggregate, you already know what are coarse aggregates. So what important tests are carried out? Crushing value, impact value, and abrasion value. So what are those quality parameters? These are given in these slides. You can see that crushing value and aggregate impact value shall not exceed 45% by weight of aggregate to be used in concrete other than wearing surface, and 30% by weight for concrete in wearing surfaces. Then aggregate abrasion value shall not exceed by 30% for aggregates to be used in concrete for wearing surface, and 50% for aggregate to be used. So these are the different types of qualities that are required, and standards have been prescribed under different BIS codes. Depending upon the requirement, the maximum size of coarse aggregate may be 40 mm or 20 mm, and the minimum size shall be 4.75 mm. So now we come to what are the different types of tests. You see, water absorption, specific gravity, aggregate impact value, aggregate crushing value, Los Angeles abrasion test, soundness test, then accelerated alkali aggregate reactivity tests. Normally these, when we go for investigation, these samples we send to the CSMRS New Delhi or other approved labs, and they carry out these tests and furnish us test results as well as a test report also. But these are the things which you must have also studied during your graduation level. Then we come to the fine aggregates. Fine aggregates means those which are less than 4.75 mm. So specific gravity of fine aggregate, silt and clay content, organic impurities, these are the various tests that we need to carry out on fine aggregates. Then accelerated alkali aggregate reactivity test. So depending upon particle size in a sample, fine aggregate are placed in grading zones 1, 2, 3 and 4. These are the 4 grading zones of fine aggregates. So you can see these zones have been prescribed in IS 383/1970. You need not learn them by rote. इसको रटने की जरूरत नहीं है, ये आपको पता होना चाहिए कि यहाँ है. वैसे भी ये वाला जो प्रेजेंटेशन है ये आपको साथ में स्टडी मटेरियल के रूप में NWA सप्लाई करेगा, तो इसको रेफरेंस के लिए आप यूज कर सकते हैं. ग्रेडिंग जोन 1 में 10 mm 4.75 डिफरेंट mm में क्या क्या फाइनल परसेंटेज होंगे, कितना कितना परसेंटेज होगा, उसके हिसाब से ग्रेडिंग जोन्स डिसाइड किए हुए हैं. Then what are the deleterious material for your concrete? So one is coal and lignite, another is clay lumps, then materials finer than 75 micron ISCs, then soft fragments, shale, and total of percentage of all deleterious material shall not exceed the prescribed limit. So fine aggregate uncrushed and crushed 5% and 2%, and for coarse aggregate maximum 5%. Now we come to the bricks. So a finished brick must conform to the IS 1077/1992. Average compressive strength of a brick is 100 kg, must be greater than 100 kg per square centimeter when tested as per IS 3495. So these are the methods. In IS 1077, permissible values are given. Methods are given in IS 3495. I have given at the end of this presentation all the BIS codes that are referred to in this presentation, as well as which are required for during investigations. So bricks shall be hand molded or machine molded and shall be made from suitable soils. Suitable soils means the soil should be free from flaws or organic materials, modules of free lime. Why free lime? Because I told you lime gets dissolved in water and then creates a cavity. So lime, it should be free from lime. All the edges must be straight and the corners shall not be damaged. ये आपके लिए, आपके जनरल नॉलेज के लिए भी जरूरी है, क्योंकि ये जब आप अपना घर बनवाएंगे या किसी का घर का बनता हुआ ऑब्जर्वेशन सुपरविजन अगर आप करेंगे, तो ये ब्रिक्स के लिए आपको ध्यान देना चाहिए. ब्रिक इज अ वेरी वेरी इंपॉर्टेंट मटेरियल, पर्टिकुलरली फॉर buildings. What is the tolerance limit? Light आ गई इधर. Then what is the tolerance limit for bricks? You see there are different types of grades in which different length, width and height are given. Thank you. Then water absorption is also prescribed, that after immersion in cold water for 24 hours, water absorption shall not be more than 20% by weight. And then efflorescence, the bricks when tested in accordance with the procedure laid down, the rating of efflorescence shall not be more than moderate. So efflorescence occurs because of presence of deleterious material present in the soil which is being used for preparing bricks. Now water. Water is an important construction material also. Apart from sustaining life, for concrete, water, quality of water is very, very important. And water quality, regular testing of water quality during concrete is a must. Now type of solid in water permissible constructions: organic matter, inorganic matter, sulfates, chlorides. These are important parts. These are different from those um, required for drinking purposes. Yes. I'll just have it. Why water is so important? Because when we mix cement with water, chemical reaction takes place. And for that chemical reaction, if there is a presence of deleterious materials or harmful materials, then the strength of concrete will be compromised. Therefore, these limits have been prescribed, especially for organic matter. Then inorganic matter, sulfates, chlorides, suspended matter, then alkalinity and also acidity. So this is, so far we have done the covered the studies are data collection, field investigations which are required, which are essentially to be carried out in the field. Now we come to one part which is both. Some data is collected from the field and some studies are carried out in the office itself. So these are very important and very specialized kind of studies. Just as hydrological analysis is a very specialized kind of study, irrigation planning is also a very specialized kind of study. So this includes assessment of land resources, soil survey, command area survey, irrigability classification, then cropping pattern, and also drainage requirement. All these are covered under data and survey requirement for irrigation planning. So for irrigation planning, we move from complexity to simplicity in detail. So macro level, micro level, macro level, micro level. Macro level planning is broad level planning. From there we move to micro level planning and then planning for on farm development. Means खेत में भी जो काम करना है, that is ऑन फार्म डेवलपमेंट. वो हम क्या क्या करेंगे? हम इरिगेशन प्लानिंग में सारी चीजें करते हैं. मैक्रो लेवल प्लानिंग में क्या करते हैं कि किस तरह की मट्टी है, किस तरह की फसलें हो सकती हैं और हमें कैनाल कहाँ कहाँ से ले जाना है, कहाँ कहाँ से डिस्ट्रीब्यूटरीज देनी है, कैसे. और माइक्रो लेवल प्लानिंग में क्या होगा कि हम कैसे कैसे माइनर्स ले जाएंगे, हम कहाँ कहाँ से हम कितना पानी देंगे, उसका रोटेशन क्या होगा. और फिर ओएफडी मतलब यह है कि खेत में, कि जैसे खेत में हमें उसको लेबलिंग करना है, उसमें फरो टाइप करना है या ड्रिप इरिगेशन करना है, अगर पानी की कमी है तो स्प्रिंकलर या ड्रिप ये करना है. लेबलिंग इज इंपॉर्टेंट, वन इंटरवेंशन ऑफ ओएफडी. देन खेत के अंदर भी अगर पानी ले जाने के लिए चैनल्स बनाना है तो वो किस तरफ से बनाना है. ये सारी चीजें जो हैं हमें देखना है इसमें. ये अब रेड में जो लिखा है इसको थोड़ा पढ़िए. During macro planning stage, the overall development planning with respect to irrigation, agriculture and drainage is to be carried out in order to improve the socio-economic conditions of the command area people. This is to be based on broad assessment of soil characteristics so as to efficiently use the soil resources of the प्रोजेक्ट एरिया. मतलब मैक्रो लेवल प्लानिंग में हमारा फोकस क्या है, किस तरह की सॉइल है, किस तरह का प्रोड्यूस वहां हो सकता है और कितना पानी हमें चाहिए होगा ताकि लोग उसमें फसल अच्छी तरह से उगा सकें एफिशिएंसी के साथ. तो हम उसमें करते क्या क्या है मैक्रो लेवल इरिगेशन प्लानिंग में. ये एक इसका मैक्रो लेवल प्लानिंग जब हम कर लेंगे तो हमारा आउटकम क्या होगा, ओवरऑल प्लान फॉर सस्टेनेबल डेवलपमेंट फॉर एंटायर कमांड एरिया. सस्टेनेबल डेवलपमेंट मतलब क्या है, आपकी सॉइल खराब नहीं होगी, आपकी सॉइल ना तो एसिडिक हो जाएगी ज्यादा ओवर फर्टिलाइजर यूज करने से, ना आपकी सॉइल वाटरलॉक्ड हो जाएगी, आपकी सॉइल रीजनरेट हो जाएगी, या रीजनरेट नहीं कहना चाहिए, रिजुवेनेट हो जाएगी अगली फसल को सपोर्ट करने के लिए, ताकि आप साल दर साल सीजन टू सीजन आप फसलें लेते रहें विदाउट कंप्रोमाइजिंग द क्वालिटी ऑफ योर फील्ड. and identify areas for detailed survey and investigation for micro level planning. इसी स्टेज पे आप माइक्रो लेवल प्लानिंग के लिए भी कहाँ कहाँ हमको करना है ये पता करते हैं। तो हम इसको देखते हैं एक बार कि हम ये कैसे करते हैं। फॉर एग्जांपल सी ग्रॉस कमांड एरिया, मतलब कहाँ कहाँ पे हम पानी पहुंचा सकते हैं। फिर इसमें कल्चरेबल कमांड एरिया, नेट इरिगेशन एरिया, net irrigable area, then water availability, what are the different types of soil, what is the existing land use and land cover, what is existing drainage, existing cropping patterns और agricultural practice क्या follow हो रही हैं, sorry, और इसमें ये नीचे जो है कुछ आया नहीं है, ये शायद इसका फॉर्मेट, ये वाले लैपटॉप का फॉर्मेट अलग है ऐसा मुझे लग रहा है। पूरा क्यों नहीं आ रहा है इसमें, मैं लेआउट इसका चेंज करता हूँ। पेज साइज, पेज सेटअप, अभी ये आया पूरा। सो मैक्रो लेवल प्लानिंग में हम क्या क्या कवर करते हैं, सॉइल टाइप्स तक के हमने देख लिया, एग्जिस्टिंग लैंड यूज एंड लैंड कवर, एग्जिस्टिंग ड्रेनेज सिस्टम, एग्जिस्टिंग क्रॉपिंग पैटर्न्स, प्रीवेलेंट स्टेटस ऑफ डेवलपमेंट की अभी फिलहाल उस पूरे ग्रॉस कमांड एरिया में जो लोग रह रहे हैं उनका सोशियो इकोनॉमिक स्टेटस कैसा है, इंफ्रास्ट्रक्चर कैसा है, मार्केट कैसा है वहां का। ये हमें क्यों चाहिए, क्योंकि हम ये देखेंगे कि अगर जो इरिगेशन इंट्रोड्यूस करने के पहले क्या स्टेटस था और इरिगेशन इंट्रोड्यूस करने के बाद क्या स्टेटस आएगा, तब हम इसका, हमने जो इंटरवेंशन किया है इरिगेशन के रूप में, उसका क्या इम्पैक्ट हुआ है लोगों के सोशियो इकोनॉमिक स्टेटस में, ओवरऑल इकोनॉमिक वेलबीइंग में। तो इसलिए हम प्री प्रोजेक्ट स्टेटस डिटरमिन करते हैं और फिर पोस्ट प्रोजेक्ट स्टेटस भी डिटरमिन करते हैं। देन इसी लेवल, इसी स्टेज पे मैक्रो लेवल प्लानिंग में डिलिनिएट कैनाल नेटवर्क, सो मेन कैनाल्स, ब्रांच कैनाल्स, इंपॉर्टेंट लोअर ऑर्डर कैनाल्स, क्रॉस ड्रेनेज वर्क्स, then they are marked on topo sheets of map 1:25,000 and all relevant details are marked on it and calculated. Say for example offtakes, full supply level क्या होगा कैनाल के लिए, then how the gradually what will be the slope, then what will be the losses, so different points पे क्या हेड अवेलेबल होगा और उस हेड अवेलेबल होने से कितनी क्वांटिटी अवेलेबल होगी और कितना हम एरिया कवर कर सकेंगे। देन आइडेंटिफाई एन रिप्रेजेंटेटिव एरिया फॉर डिटेल्ड सर्वे। नाउ एन रिप्रेजेंटेटिव एरिया फॉर डिटेल्ड सर्वे मतलब क्या है, डिटेल्ड सर्वे हम उन एरियाज का, मान लीजिए कि पूरे ओवरऑल ग्रास कमांड एरिया में आपके लगभग 3 मेजर सॉइल टाइप्स हैं। So you will identify 3 representative areas for detailed survey. Say for example 10% of each soil type, वो एरिया आप लेंगे और फिर उसका डिटेल्ड सर्वे करेंगे, दैट विल बी फॉर माइक्रो लेवल इरिगेशन प्लानिंग। हमने जब ये ब्रॉड मैक्रो लेवल प्लानिंग किया तो हमको पता चला कि 3 टाइप की सॉइल्स हैं, मेनली होंगी तो वैसे ज्यादा, लेकिन ब्रॉडली 3 टाइप्स हैं। तो हम इन 3 टाइप्स में एक एक एरिया सेलेक्ट करेंगे इन तीनों को रिप्रेजेंट करने के लिए एट द रेट 10% ऑफ द एरिया। तो 10% एरिया ताकि हम कर लें और वो 10% को हम डिटेल में करते हैं। और इसी समय जो हम मेन सॉइल टाइप एरिया है जो हमने एन रिप्रेजेंटेटिव टाइप लिए हैं, उन्हीं में से कुछ एरियाज को सेलेक्ट करते हैं ऑन फॉर्म डेवलपमेंट के लिए सर्वे करने के लिए। तो अब हम आते हैं माइक्रो लेवल इरिगेशन प्लानिंग पे। माइक्रो लेवल इरिगेशन प्लानिंग का आउटकम क्या है, हम पहले देखें कि माइक्रो लेवल इरिगेशन प्लानिंग हम क्यों करते हैं। क्योंकि इसको करने के बाद हम किस तरह से हमारा जो मैक्रो प्लानिंग है सही है कि नहीं है, पहले तो यही हम कंफर्म करते हैं कि जितना पानी हमने सोचा था कि यहाँ इस खेत में पहुंचेगा, माइक्रो लेवल पे जाके जब हम उसको एनालाइज करते हैं तो पता चलेगा कि पहुंच रहा है कि नहीं पहुंचेगा, तो उसका कंफर्मेशन है। और दूसरा ये है कि हम जो ऑन फार्म डेवलपमेंट वर्क्स हैं उनको हम सही तरीके से प्लान कर सकेंगे, और जो रिप्रेजेंटेटिव एरियाज हमने सेलेक्ट किए हैं वहां हम जब डिटेल्ड टेस्टिंग करेंगे, सॉइल की इरिगेबिलिटी क्लासिफिकेशन करेंगे, तब हमें पता चलेगा कि वास्तव में हमें कितनी कैसे इरिगेशन देना है, और इस सॉइल और इस इरिगेशन के लिए कौन सी क्रॉप्स बेहतर रहेंगी फार्मर्स के लिए। तो दिस इज द आउटपुट दैट वी डिराइव फ्रॉम माइक्रो लेवल इरिगेशन प्लानिंग। हमारे पास 15 मिनट 18 मिनट का टाइम अभी बाकी है, वी विल फिनिश इट। तो अलाइनमेंट ऑफ कैनाल्स एट डिफरेंट ऑर्डर्स, देन क्रॉस ड्रेनेज स्ट्रक्चर्स, सॉइल मैप्स में लैंड यूज हम देखते हैं, इरिगेबिलिटी क्लासेस देखते हैं फ्रॉम द इरिगेशन पॉइंट ऑफ व्यू, सुटेबिलिटी ऑफ सॉइल्स, एंड देन लैंड की कैपेबिलिटी एंड सुटेबिलिटी। क्रॉप के लिए लैंड की कैपेबिलिटी क्या है, उसमें क्या किस किस तरह के न्यूट्रिएंट्स हैं, और वो किन किन क्रॉप्स के लिए सुटेबल है। फिर अल्टीमेटली हमें, क्योंकि कैनाल हमें पास करना है, तो जियोलॉजिकल एंड जियो टेक्निकल डिटेल्स भी देखने पड़ते हैं। जियोलॉजिकल डिटेल्स मैंने आपको बताया जियोलॉजिकल क्या है, और जियो टेक्निकल मतलब क्या है, सॉइल से रिलेटेड इंजीनियरिंग प्रॉपर्टीज का डिटर्मिनेशन। जियोलॉजिकल मींस जो सब स्ट्रेटम में जो ओवरबर्डन है और जो रॉक है उनकी इंजीनियरिंग प्रॉपर्टीज का डिलिनिएशन एंड डिटर्मिनेशन। तो ये है जियोलॉजिकल एंड जियोटेक्निकल डिटेल्स। देन क्वालिटी एंड स्टेबिलिटी ऑफ सुटेबिलिटी ऑफ इरिगेशन वाटर, एज आई टोल्ड यू इट इज अ वेरी इंपॉर्टेंट क्राइटेरिया। अगर आप कैडमियम, अगर जैसे दिल्ली में हुआ है, दिल्ली में कई बार ये पाया गया था पहले कि वहाँ जो बड़े बड़े सीवर्स चल रहे हैं, वो ओपन ड्रेन्स हैं, उनसे इरिगेट करके लोग बाग क्रॉप्स वेजिटेबल्स उगा रहे थे, तो वहां कैडमियम था, तो वो कैडमियम वेजिटेबल्स में भी पाया गया था। तो इसलिए इरिगेशन वाटर को सही होना बहुत जरूरी है। तो इरिगेशन वाटर जो है, एक हमने देखा कि वाटर एज ए कंस्ट्रक्शन मटेरियल, नाउ वी आर सीइंग वाटर एज एन इरिगेशन मटेरियल, एंड थर्ड ये एक तरह का लाइफ सस्टेनिंग ही है, जो हमारे जैसे ड्रिंकिंग वाटर के लिए जो रिक्वायरमेंट है वही मोर और लेस, हालांकि उससे कम स्ट्रिंजेंट क्राइटेरिया है इरिगेशन वाटर के लिए, लेकिन मोर और लेस आप कह सकते हैं कि लगभग वैसा ही वाटर चाहिए। देन अवेलेबिलिटी ऑफ कंस्ट्रक्शन मटेरियल्स, क्योंकि आपको ये क्रॉस ड्रेनेज स्ट्रक्चर्स करने हैं, आपको कैनाल्स पास करनी है, इसलिए क्या क्या कंस्ट्रक्शन मटेरियल लगेगा ये भी आप फाइंड आउट करते हैं। देन ऑन फॉर्म डेवलपमेंट वर्क्स, ऑन फॉर्म डेवलपमेंट वर्क्स में आप क्या करते हैं, आप एक्चुअल सर्वे एंड स्टडीज करते हैं, टोपोग्राफिकल सर्वे एक लिमिटेड एरिया में, मतलब चक प्लानिंग बोलते हैं। चक इज क्या, व्हाट इज ए चक इज अ वेरी स्मॉलर पोर्शन ऑफ कल्चरेबल कमांड एरिया से एक 8-10 खेतों का एक समूह है, जो लगभग 40,000 मतलब 5 से 8 हेक्टेयर का जो ब्लॉक है, वो इन ए चक ऑफ 40 हेक्टेयर चक्स। तो हम एक स्मॉलर वैल्यू लेते हैं, बहुत स्मॉल भी नहीं, से 40 हेक्टेयर, 40 हेक्टेयर का एक चक, उसमें कई खेत हो सकते हैं। ठीक है, तो 40 हेक्टेयर मान लिया, एक एग्जाम्पल है ये, नॉट कोई हार्ड एंड फिक्स रूल नहीं है। अगर आपका कल्चरेबल कमांड एरिया छोटा है, आप 10 हेक्टेयर का भी चक ले सकते हैं, या आपकी लैंड होल्डिंग्स अगर बहुत स्मॉल हैं, क्योंकि कई जगह क्या होता है, फार्मर्स आर वेरी मार्जिनल फार्मर्स, या जिनकी लैंड होल्डिंग्स बहुत छोटी छोटी है, तो वहां आप चक साइज छोटा भी कर सकते हैं डिपेंडिंग अपॉन अवेलेबिलिटी ऑफ वाटर। तो वो चक साइज को लेके और उसमें 1% ऑफ सीसीए आप सेलेक्ट करेंगे, ईच रिप्रेजेंटेटिव एरिया ऑफ ब्रॉड सॉइल टाइप्स। हमने मैक्रो लेवल पे एन नंबर ऑफ रिप्रेजेंटेटिव एरिया सेलेक्ट किया था। एग्जाम्पल मैंने दिया था कि 3 रिप्रेजेंटेटिव एरियाज, तो उन तीनों रिप्रेजेंटेटिव एरियाज में 1-1% हम सेलेक्ट करेंगे ऑन फार्म डेवलपमेंट स्टडीज करने के लिए, और मैक्सिमम साइज होगा 1000 हेक्टेयर का। उसमें हम ये डिटेल्ड स्टडीज करेंगे कि किस तरह से हम उसका पूरा कंटूर प्लॉट करेंगे हम। देन कंटूर प्लॉट करने के बाद हाउ दी डिस्ट्रीब्यूटरीज, माइनर्स एंड वाटर कोर्सेज विल बी लेड ऑन द ग्राउंड। ये डिटरमिन करेंगे ड्रेनेजेस कहाँ से होगा, क्रॉस ड्रेनेज स्ट्रक्चर कहाँ बनेंगे, डिस्ट्रीब्यूशन स्ट्रक्चर्स किस तरह के होंगे, और जो मैप्स और ड्राइंग्स बनेंगी उसका स्केल भी डिफाइंड है इसके लिए। 1:2500 is the scale and contour interval is of only 0.5 मीटर। तो खेत की प्लानिंग के लिए आप ये कह लें, अब एक बड़ा चक है, मतलब एक बड़े कई खेत हैं शामिल हैं, सपोज करो एक बड़ा फार्मर है, उसका बहुत लंबा चौड़ा फार्म है, तो उसके प्लानिंग अगर सपोज करो वो उसी एरिया में पड़ रहा है, तो उस बड़े एरिया की प्लानिंग के लिए 0.5 मीटर का कंटूर इंटरवल होगा और स्केल होगा 1:2500 का। तो अब हम देखते हैं कि क्या है हमारे BIS कोड्स। तो मैंने कई बार बहुत सारे BIS कोड्स का नाम लिया, ये लिस्ट है आपके BIS कोड्स की, ये करीब 22 BIS कोड्स हैं जो हमको देखने पड़ते हैं अपने इस काम के लिए। ये लिस्ट है यहाँ, ये आपकी जो गाइडलाइंस जो मैंने शुरू में बताया था उस गाइडलाइन में पीछे अनेक्सर में ये सारे कोड्स दिए हुए हैं। तो ये इससे हमारा ये जस्ट मिनट, तो अभी हम इसमें ये हमारा मेजर है, ये फिनिश हुआ। अब लेकिन इसके बाद हमारा बचता क्या है, इसके बाद जो हमारा बचता है वो आता है बेनिफिट कॉस्ट इकोनॉमिक इवेल्युएशन एंड एस्टिमेशन एंड कॉस्टिंग। तो एस्टिमेशन के लिए आपको एक अलग से आपका एक लेक्चर है, तो एक चैप्टर होगा उसमें। ये मेजर जो इन्वेस्टिगेशंस मैंने बताया आपको, ये मेजर इन्वेस्टिगेशंस हैं आपके जो इसमें लगते हैं। और उसके बाद अब एक होता है एक्सेस एंड इंफ्रास्ट्रक्चर सर्वे। एक्सेस एंड इंफ्रास्ट्रक्चर सर्वे में आप क्या करते हैं कि आप अपने डैम तक कैसे पहुंचेंगे। पहली बात तो यह है कि आपको इन्वेस्टिगेशन के दौरान पहुंचना है, और दूसरी बात यह है कि ड्यूरिंग कंस्ट्रक्शन न सिर्फ आपको पहुंचना है लेकिन बड़ी बड़ी मशीनरीज को भी पहुंचना है। बड़े बड़े ट्रक्स आएंगे जिनकी लेंथ, जिसमें एक्सल लोड ज्यादा होगा, मल्टीपल व्हील्स होंगे, मल्टीपल एक्सल्स होंगे, तो उनकी लेंथ बहुत ज्यादा होगी, तो आपको रोड वाइडनिंग कहाँ कहाँ करनी पड़ेगी, उनका वेट ज्यादा होगा, तो आपको कहाँ कहाँ ब्रिजेस स्ट्रेंथन करने पड़ेंगे। ये सारा आपको स्टडी करके एक एक्सेस एंड इंफ्रास्ट्रक्चर का चैप्टर होता है, उसमें ये चीजें आपको इंक्लूड करनी पड़ती हैं। तो एक्सेस एंड इंफ्रास्ट्रक्चर, एक इंपॉर्टेंट पॉइंट इंफ्रास्ट्रक्चर का ये भी है कि ड्यूरिंग कंस्ट्रक्शन वहां पर लोग रहेंगे, इंजीनियर्स रहेंगे, लेबरर्स रहेंगे, कॉन्ट्रैक्टर्स के भी लेबरर्स रहेंगे, कॉन्ट्रैक्टर का एक रिप्रेजेंटेटिव रहेगा, कुल मिला के एक कॉलोनी आपको वहां एस्टेब्लिश करनी पड़ेगी। तो आपको वो कॉलोनी की प्लानिंग भी देना होगा, और उस कॉलोनी की प्लानिंग में आपको सभी वो जरूरतें देनी होंगी जो एक परिवार के लिए जरूरी होती हैं। फॉर एग्जाम्पल हेल्थ फैसिलिटी, एजुकेशन फैसिलिटी, ये आपको वहां प्रोवाइड करना पड़ेगा, वाटर सप्लाई, सैनिटेशन, ये सारी फैसिलिटीज, एक टाउन आपको वहां प्लान करना है कंस्ट्रक्शन के लिए। तो इस तरह से अब ये हमारा ब्रॉडली एक, जैसे मैंने बताया कि एक एस्टिमेशन का वॉल्यूम होता है, एस्टिमेशन के ऊपर आपका एक सेपरेट लेक्चर है, तो उसको अभी मैं नहीं कवर कर रहा हूं। और दूसरा एक है इकोनॉमिक इवेल्युएशन, तो वो एस्टिमेशन के साथ ही लिंक्ड अप है कि बेनिफिट और कॉस्ट रेशियो आप कैसे निकालते हैं। सो दीज आर द गाइडलाइंस फॉर प्रिपरेशन ऑफ डिटेल्ड प्रोजेक्ट रिपोर्ट। अब हमारे पास अभी 10 मिनट का समय है, आप लोगों का अगर कोई क्वेश्चन हो तो आप लोग मुझसे पूछ सकते हैं। कोई क्वेश्चन आज अभी तक के गाइडलाइंस पर या इस पर? मैंने कोशिश की कि जो समय दिया गया है उसी में, निर्धारित समय में मैं खत्म करूं। अदरवाइज हमेशा ये होता है कि मैं बहुत ज्यादा समय ले लेता हूं, तो आई ट्राइड दिस टाइम टू फिनिश इट इन टाइम। और 10 मिनट का समय रखा है कि आपके अगर कोई प्रश्न हो, अगर अभी नहीं भी आ रहे हो मन में प्रश्न, तो आप मुझे प्रश्न बाद में भी भेज सकते हैं या टेलीफोन से मुझसे पूछ सकते हैं, कि अगर यदि कोई क्लैरिफिकेशन चाहिए तो।
So no questions. So here I conclude my presentation. So Saurabh, now
यस सर।
it's your turn.
ओके सर, तो किसी पार्टिसिपेंट्स को कुछ पूछना है, आपका कोई क्वेश्चन है तो पूछ लीजिए, अदरवाइज हम सेशन क्लोज करते हैं यहाँ पर। एनी ऑफ द पार्टिसिपेंट? ठीक है, किसी का कोई सवाल नहीं है तो सर ठीक है, देन वी क्लोज द सेशन। सो थैंक यू सो मच सर फॉर डिलीवरिंग द 2 सेशंस टुडे। और कल भी आप रहेंगे सर हमारे साथ, वी हैव अनदर 2
श्योर।
सेशंस टुमारो। सो थैंक यू
यस।
फॉर टुडेज सेशन सर, इट वाज अ वेरी comprehensively you have covered all the aspects of the DPR preparation, various chapters that are included in a DPR, and briefly you have touched upon each of the chapters, how they are done, and I am sure that it must have been very fruitful session for all the participants. So thank you so much sir, on behalf of National Water Academy I convey my regards for delivering these 2 sessions, and hoping to see you tomorrow again for the 2 sessions on SOR and preparation of estimates sir.
Thank you very much, Saurabh. And I am deeply grateful to National Water Academy and Central Water Commission for for giving me continuously these opportunities to keep myself academically reinvigorated from time to time. And I really enjoy these sessions. And though this time there are not question answers, but then they are the motivations for continuing continuing delivering these lectures. So I am indeed deeply grateful to you as well as to NWA and CWC. Thank you very much to all the participants for giving very patient and silent listening. Thank you.
Okay, thank you sir.
Okay, thank you. So I am closing it now.
Yes sir, sure sir.
Okay, thank you.
And so to all the participants, so now we break for lunch, and we will meet after lunch at 3 o'clock for the afternoon session on monitoring and appraisal of projects.